Application of Kirchhoff's rules. Use Kirchhoff's rules to determine the current flowing through 40 ohm resistor. So here a network is given. Network is having 2 cells and 3 resistors. So how to find the current through 40 ohm resistor? That can be possible by applying Kirchhoff's rules. So there are 2 Kirchhoff's rules, Kirchhoff's current rule and Kirchhoff's voltage rule. Kirchhoff's voltage rule is also known as Kirchhoff's loop rule. So let us see how to apply Kirchhoff's voltage rule to different loops. So here first of all we are considering loop ABCD. So in this network loop, this loop A, B, C, D, that loop. So what is Kirchhoff's voltage rule? It is stated that for a loop involving the cell, the total potential drop that is equal to the EMF of the cell. We know when a current is passing through a resistor or through a device, that will create a potential drop. So the statement is that for a loop involving the cell, the total potential drop is equal to the total EMF of that cell, the EMF of that cell. So here in the first loop EMF is 80 volt, the potential drop that is I1 is the current through 20 ohm, potential drop in this that is 20 I1, I into R, and here the potential drop is equal to I into R, that is 40 into I1 minus I2. Now this voltage rule, it is also stated that is for a loop taken in a definite order, or for a loop taken in a preferred direction. What do you mean by that definite order or preferred direction? This is nothing but the direction of current in that loop. So sometimes there will be different currents, means currents flowing in the different directions. So in this loop this is simple because we know this positive terminal and current is coming in this way and flowing through this way, and the remaining current through the other path also. So this is negative terminal. So the direction of current is very evident in this. So I1 is the current from the first cell, and from C, from this junction, a part is coming as I2. So the remaining is flowing as I1 minus I2 through 40 ohm resistor. We have to calculate I1 minus I2. So here the direction of current is very clear, and also if there are many cells, then we have to consider the cell having the greater EMF, and in this that also clear, this is the cell having greater EMF. So better we can take we can prefer the direction of current in that direction itself. Means the preferred direction is the direction of current coming from the higher EMF cell. So each current will be creating its own potential drop. Now the current flowing in the preferred direction, the potential drop created by that should be given a positive sign. So here we know I1 is coming in this way, and we can say that is a clockwise direction, and I1 minus I2 that also in this way, that also clockwise direction. So both currents are following the clockwise direction. Suppose we prefer that direction, then the potential drop created by the currents flowing in the preferred direction, that should be given the positive sign, same sign. So 20 I1, the potential drop. Next potential drop 40 into I1 minus I2, that is equal to the EMF. Means the total potential drop is equal to EMF of that cell, that is algebraic sum of products of current and resistances, that is equal to EMF of that cell. And simplifying, dividing by 20, then I1 plus 2 I1, that is 3 I1. So we got equation number 1. Now applying Kirchhoff's rule to the other loop. The other loop, this one, D, C, F, E. And again the direction of current is important. First of all we have preferred this direction, that is direction of current from the 80 volt cell. That is evident, the current is flowing in this direction itself. Anyhow, the potential drop in the second loop, we know two devices are there. And this I1 minus I2 as viewed from the first loop, earlier we have considered that it is in the clockwise direction. Now the same current as viewed from the second loop, we know that is coming in this way, that is anti-clockwise, that is in a direction opposite to the preferred direction. So if we are taking the potential created due to current flowing in the preferred direction as positive, then the potential drop due to the current flowing in a direction opposite to the preferred direction should be given negative sign, that is minus 40 into I1 minus I2. And this I2, okay, that is already in the clockwise direction, so that is 10 I2, that is equal to 40, and dividing by 10, then simplifying and multiplying throughout by a negative sign, then equation 2 is obtained. Now equation 1 is multiplied by 4, so 4 into 3, 12 I1, so we named it as equation 3. And equation 2 is multiplied by 3, so 3 into 4, 12 I1 minus 15 I2 is equal to, named as equation 4. Now comparing 3 and 4, we know I1 terms are similar, so we can eliminate I1, that is we can subtract 4 from 3 or 3 from 4. Suppose equation 3 minus 4, I1 terms are eliminated, then we are finding I2. I2 is 4 ampere, and substituting the value of I2 in any of the above equations. Suppose we are substituting in the equation 1 itself. Equation 1 is 3 I1 minus 2 I2 is 4. 3 I1 is equal to 4 plus 2 I2. I2 is equal to 4. So we are getting 3 I1 as 12, or I1 is equal to 4 ampere. I1 also we got 4 ampere. Earlier we got I2 as 4 ampere. So the current through 40 ohm resistor, we have seen that I1 is the current coming in this way, and I2 is flowing in this way, and remaining, that is I1 minus I2, that is flowing through 40 ohm resistor. So the current through 40 ohm resistor is I1 minus I2, that is 4 minus 4, 0.